Welcome back. This is the 16th Isaac Asimov Memorial Panel Debate. It's in its 15th year. There was one year where we had two. There was so much going on. I like learning just briefly, for how many people is this their first occasion to attend the Asimov panel? Welcome. Where have you been the past 15 years? That's the real question. I'm Neil deGrasse Tyson. I'm the Frederick P. Rose Director of the Hayden Planetarium. And we do this once a year in the spring. We find a topic of particular scientific vitality that might have some controversy, but it's more a topic that is on the frontier. And we bring it to you through a panel. And that would be the Isaac Asimov Memorial Debate Panel. This event was started by a bequest of the friends and family of Isaac Asimov. He was a friend of this institution. He did much of the research for his countless books in the libraries and halls of this institution. And Janet Asimov, his widow, as well as friends and family, came together to provide an endowment to sustain this in perpetuity. So I want to just publicly thank the friends and relatives of Isaac Asimov. Yeah. Two other quick people I'd like to thank. Laura Jean Checky, who helps manage this event, as well as my executive assistant, Elizabeth Stachow. Today happens to be her 60th birthday, and she's working on her birthday. Because that's how devoted we are. Yes, she's been 60 times around the sun. That's how we talk about it here. You know, that's how we roll at the planetarium. Tonight's topic is all about water. If you're from the Midwest, that would be water. And water is really all over the place. The real question is it the kind of water we can use? Water all around, not a drop to drink. Famously quoted from, I believe, the rhyme of the Ancient Mariner. And so we thought we would put together a panel to discuss all facets of what water is, where it comes from, what its future will be. And we have a crack team of water experts to take us there. And let me introduce them for you. We will begin with, by the way, all their bios are in the program, so I will not spend time reading the entirety of their bio because I want to get straight to this panel. Oh, and by the way, the way we're going to conduct this, it's not a point-counterpoint debate style. It's really a conversation. It's as though you walked into a bar and the six of us are there talking about water and you're eavesdropping on our discourse. That's what's going to happen tonight. There'll be no PowerPoint slides, no polished deliveries. We're just having a conversation, and you're eavesdropping on it. And at the end, there'll be time for questions and answers. I'd like to first introduce a retired general from the U.S. Air Force who specializes in, among other things, the protection of strategic assets. Join me in giving a warm welcome for General Chuck WALD. The next is an honor and a privilege for me to introduce a longtime friend of mine. We've served on boards together. She is the administrator, the chief person of NOAA, the National Oceanic and Atmospheric Administration. Give me a warm welcome for Kathy Sullivan. Kathy. We need some geology discussion here, and So we combed the world to find who are some good geologists who specialize in water, and we call those folks hydrologists. And I found one who's actually appeared as a guest on my radio show, Star Talk. She's an assistant professor in geosciences at Penn State University. Give a warm welcome to Tess Rousseau. A lot of our understanding of water comes to us, water in the universe comes to us from space, so we needed some kind of representation from NASA here, and we found just that person, the chief scientist of NASA. Give a warm welcome for Ellen Stofan. Ellen. And finally here, there's a longtime friend and colleague of mine. We came up in graduate school around the same time. She parted into the solar system, I into the rest of the universe. But she's one of so she stayed like parked in the neighborhood. She's one of the world's experts on comets and other presence of water in the solar system. I'll give a warm welcome for Heidi Hammel. Heidi. So what I'd like to do is, just so you can hear their voices and sort of get a sense of where they're coming from in the universe, if you just spend 2 minutes, just let me hear your name again and just sort of what your official titles are and where you're coming from, General.
Thanks, Neil. I'm Chuck WALD. I live in Washington, D.C. I was with the United States Air Force for 35 years before I retired. The last assignment was Deputy Commander for European Command, U.S. European Command. We had 92 countries in that command that we were responsible for. And previous to that, I led the first 3 months of the Afghan air war. Currently, I'm with Deloitte as a vice chairman for our federal practice and do global defense issues.
Excellent. Thank you. Just a mic check. Is that loud enough for people? Do you want it a little louder, or? Can we get a little louder on that, if we could, please? Thanks. Kathy, go ahead.
Kathy Sullivan. I'm currently the Undersecretary of Commerce for Oceans and Atmosphere and NOAA Administrator, as Neil said. I actually started my life as a solid rock geologist, specializing in the deep sea floor. Then got a magical opportunity to go fly in space and look at this little planet with my own eyes, and that's really where the passion to take the science and knowledge of our planet and bring it back to Earth and really make it connect to the challenges and decisions that we all face every day was struck in me. So hence the loop back to NOAA. That's what we do. We're America's environmental...
We'll check on the microphone here. Hold on.
Oops. Funny.
What's he doing there? What?
Yeah. No, really, that was just the mic switch. No? You sure it's on at the board? It worked. It worked in the mic check.
Yeah, we did actually have a mic check earlier this evening.
Yes. Do you want to use mine?
While they're fixing her mic, allow me to announce that this day is the 25th anniversary of Kathy Sullivan deploying the Hubble Space Telescope in space. Kathy.
Small inside baseball story, I did not actually get to pull the trigger that released it. Steve Hawley did that. And Bruce McCandless and I were locked in the airlock where we had almost had to race outside to crank open the solar array that hung up for a while. So I only worked on the telescope 5 years and never got to see it deploy.
Okay. Oh. But last week and this week were big weeks. It was the 25th anniversary of the launch of the Space Shuttle mission to repair the Hubble. Kathy was on that mission, and we're all grateful for your efforts there and the rest of your team to make that happen. Hubble is an important piece of American history, of scientific history, and it'll be remembered forever. So I don't know if your microphone is still fixed.
No.
Oh, so no, oh, let's move on and we'll come back. So yes, Tess.
Sure. My name is Tess Russo. I'm an assistant professor at Penn State in the Department of Geosciences. And I study how water moves between the surface of the Earth and the groundwater. I study the physical dynamics of those processes. Most of my work is in the context of agricultural water management. And I do a lot of work in developing countries, trying to figure out how much water they have, what the extents of their resources are, how they can use them in sustainable ways to feed themselves and make sure they have enough water to feed their next generations.
Were hydrologists always around? I mean, is that a forever thing in the world of geologists?
No, I don't think so. I think one of the earliest hydrologists was a British fellow.
I mean, how long ago? How long ago?
Like late 1800s, maybe?
Oh, okay.
Or no, mid 1800s, because that's when Darcy was.
It's older than the century. I was just wondering.
Oh, yeah.
The thought of what water is doing in its cycle might have been an emergent thought, but it's not. Okay.
No, they were trying to figure out how it moves through sand and clay differently.
Okay, cool. Ellen. Yeah.
I'm Ellen Stofan. I'm the chief scientist of NASA. I'm actually a planetary geologist. I study volcanoes around the solar system. But as chief scientist of NASA, I get to look across all of the science we do at NASA, from the work we do up on the International Space Station every day, getting with our astronauts, getting humans ready to go to Mars, hopefully in the 2030s, to astrophysics, the Great Hubble mission, which my boss, Charlie Bolden, was up with Kathy and helped to deploy.
Her boss is the head of NASA, just to make that clear.
Studying the sun, studying the planets of our solar system, and of course, studying our favorite planet, Earth.
Nice. Yeah, Heidi.
My name is Heidi Hammel.
Oh. Uh-oh.
Green.
Oh, you on?
Green.
Okay, let's go.
My name is Heidi Hammel. I am currently executive vice president of a group called AURA that runs very large telescopes, including the Hubble Space Telescope. So we have been celebrating this past week. My background is as a planetary astronomer, but I also do astrophysics. I've looked at water on comets. I've looked for water on Jupiter. I've looked extensively at planets that have water inside them. And I recently participated in a NASA press conference talking about the water inside Jupiter's moon Ganymede. So there's water all over the solar system and on planets around other stars as well. And we can talk about that as we move forward.
If water's everywhere, why are we having a problem here on Earth? It's all your fault. Also, we hear that comets are mostly water, right? And do we know where Earth's water came from? Let's start there. Presumably, you would have the answer to that. Because did it come from space? Did it come from volcanoes? Like, who brought the water here?
Well, that's a topic that we discuss quite a bit in planetary astronomy. Certainly some of the water just came from the solar nebula as it formed. There were little bits of dust and ice throughout our solar system as it was forming initially. And some of that water is intrinsic to our planet. But at the same time, we really expect that a lot of water was delivered to our planet as our solar system got stirred up. There are some theories that say at one point in time, Jupiter, Saturn, Neptune, and Uranus were the order of the planets. And there was a whole lot of icy planetesimals out there filled with water. And at some point when Jupiter, Saturn, Uranus, and Neptune interacted with one another, Uranus and Neptune switched places. And when Neptune did that, when it swooped out into that cloud of debris, a lot of material was delivered into the inner solar system. And that could be where some of the water has come from. So there's many different places that water could come from.
So you're saying that the debris in the outer solar system went unstable in the presence of this new gravitational configuration. And when you go unstable, you lose your orbit, you descend into the inner solar system, and it's raining rain.
It's raining rain and rocks, like when the dinosaurs, when the comets or asteroids were delivering death to the dinosaurs, they were delivering water as well, probably.
Water as well. So wasn't it a point of controversy whether we use the water from the birth material of the solar system versus whether it came later? Not that I know anything about, but I remember reading about that.
Will my mic ever come on, do you think?
I don't know. We'll just stand here. We can do this.
Well, yeah, I mean, that's the whole point of science, Niels. It's just constant controversy.
So Ellen, what are some other sort of hot places? I mean, hot as in scientifically interesting places. You have to be careful with, lingo here. In the solar system, because NASA has a mantra, I remember, and it's follow the water. Is that still the mantra? And presumably, it's not just because we want to drink of water, but there's more going on there. So could you highlight that for us?
Well, and I think that's important. You really have to step back and say, why do we care so much about water? Well, let's go back to the fact that we are mostly made of water. We rely on water. Here on Earth, life evolved in water, and we actually remained in the oceans for billions of years before we managed to become as complex as us. So we think that water is key to life, and it's not just
to life as we know it.
To life as we know it.
Okay.
But it's not
just trying to loosen that up.
This isn't completely an Earth bias, though, Neil, because water has really unusual properties. It's a solvent. It's a bipolar molecule that we think has really unique properties.
People are bipolar, but that's a different use of the term.
That's a different use of the term.
Just to clarify.
Positive and negative charge.
Yes.
So because of those unique properties of the water molecule, we think that contributed to the formation of life. So when we go out and follow the water in the solar system, out into the galaxy, out into the universe, we're following that ingredient, liquid water, that we think is critical for the formation of life. So where do we look? Mars. We know there was water on the surface of Mars several billion years ago, flowing on the surface maybe for as long as 1 billion years. Now that time period is important because it takes time for life to evolve. It takes time for life to get complex. So many of us in the scientific community have a pretty strong belief based on science that at some point life was likely to have evolved on the surface of Mars. The hard point is going to be finding it. And don't even get me started on the outer solar system. Heidi mentioned the fact that Ganymede, one of the moons of Jupiter, has liquid water in its interior. So does Europa. So does Enceladus, which is a moon of Saturn. All of these places are rich environments for us to go search for extraterrestrial life. Microbes, again, not little green men.
Or little green women. Yes, okay. Tess. So Tess, there's water everywhere, and here on Earth, yes, we have water, but now we're getting picky about our water because some of it is salinated, some of it is not, and we can't really use the salinated water, and we don't know how to convert it efficiently yet. And so this creates your profession, basically, right? The cottage industry that is the hydrologist. Right?
Yeah, we're doing quite well.
Is that right? Eternal work for you. Yeah, so we take a lot for granted here. I go to the bathroom and just turn the knob, and water comes out of the wall. And my parents, who are actually here this evening, growing up, I mean, they've seen a lot, and they were born in the 1920s. And I remember we complain about something or other in the apartment, and they say, "You're complaining, and you have water coming out of the wall?" And I'm thinking, where did they get their water from when they grew up? I don't know, but it apparently didn't come out of the wall. So we take so much for granted here in the United States. What is it we should know about in these developing worlds where access to potable water is scarce or non-existent?
Well, so in most of the areas that I'm working in, people are either collecting their water by hand from a nearby resource, or digging a shallow well, or collecting rainwater. And the challenge is that none of those are very reliable. The fact that water comes out of the wall reliably is the key part. And so most of my work has to do with agricultural water use, so how much water do people have for irrigation? And that's becoming increasingly important as the climate is changing and precipitation patterns are changing, and people can no longer rely on the natural rain patterns to irrigate their crops.
What you mean by natural is what they had grown accustomed to in their previous traditions.
Right.
Okay. And so what's the future of this?
It's uncertain. I think
Okay.
the future is...
That's so you know you're speaking to a scientist. When they don't know something, they'll say, it's uncertain. Everyone else says, I have the answer, whether or not they actually do. Yeah.
So the future is working with people from NASA and NOAA to get a better understanding of how we as humans are affecting the climate and how it's changing natural, how those two are working together so that we can make smarter choices about how we use water. And so choosing what crops to grow, when to grow them, like those are the decisions that we make.
Glaciers are fresh water, aren't they?
Yeah.
So we are already melting the glaciers, so doesn't this help out? Is that?
It is helpful, I guess, in some respect, but it's not a long-term solution. So.
Kathy, NOAA, they don't have their own satellites, is that correct?
We do have our own satellites. Are you kidding? I'm 0 for 2?
Yeah.
Yes?
If we can up the gain on that, maybe? Okay.
We do have our own satellites.
Okay. What? But you don't want, NASA launches them for you?
Yeah, so what we don't have is we don't have our own satellite design, development, acquisition, engineering cadre of people because the country's got a fabulous one in NASA. Called NASA. So why build a second one? Agencies actually, believe it or not, government agencies actually do things together to make some efficiencies happen. So this only goes back to the very first time that the United States had weather satellites. NASA, we set the requirements now, NASA builds them for us, they contract to do the launch, and then it cuts back over to NOAA.
Okay, and so what do you there's ocean and atmosphere in your acronym, okay? And so what are you trying to do for us?
Yeah, so this planet is actually a system of systems. When I was in school, you could look at a cartoon of the Earth with brown mountains and green fields and light blue sky and dark blue water, and you could pick a color. And you could spend your whole career just doing that. And around the 60s...
Your whole career working in one of those colors?
Yeah, I'll just do the brown dirt, or I'll just do the deep blue ocean. And there was so much still to know and understand about each of those domains. You could spend, and people for generations had, spent a whole career just looking at how one domain works. Around the middle of the last century, in the 60s in particular, we realized it's actually the links between them that are really critical. The oceans drive our weather and our climate. The atmosphere produces the input to the hydrological cycle on the freshwater side.
Hydrological as the water cycle.
As the water cycle.
So why don't you say water cycle?
We can say water cycle. They knew what I meant.
No, in my field, in astrophysics, we have simple vocabulary. I'm amazed,
Sure you do.
Hydrologic cycle, it's the water cycle, right?
It's the water cycle.
It's the water cycle, okay.
So it's the connections that matter, and NOAA was created in 1970 out of existing pieces to do that integration, number one, make the science actually connect across those fields, and number two, and more importantly, make that knowledge connect back to society. So our roots always have been about making the nautical charts, not for the sake of maps, but so that commerce could go smoothly and safely along our shores. Do the weather, not just because it's cool stuff, but because ranchers and farmers out in the Midwest of the United States in the 1870s, critically needed to know when the blue norther is coming in.
Okay, I hadn't fully appreciated that until just this minute. So I'd always known, I knew but never understood that NOAA, in fact, ultimately reports to the Secretary of Commerce.
That's true.
And so it wasn't conceived as a science agency for the sake of science. It was conceived as a science agency to serve oceanic commerce.
It was conceived by the 1970s, when NOAA was put together, it was conceived as a science-based services agency to serve the American people and the American economy.
And the American, but I'm just saying, because if you serve the economy and there's money involved, it means stuff, you'll have a real budget, and
So, we're as a country kind of more fond of new toys than of the ongoing maintenance of things.
Right, of course. So General, there are regions of the world, we think of conflict typically as political, as maybe even economic, but I don't know that we much think of conflict in terms of terrain or water, or can you share with us what what your tea leaves tell you about the future of water as a resource or as a strategic asset?
Yeah, I mean, first of all, it's interesting to be with all these scientists here that are doing good things for us. Some maybe far out, but so my sphere of concern is a little bit more near term and probably a little more kind of focused on the Earth. But the issue about natural resource.
I'm sorry. Yeah. Just the way you said it was so casual. Yeah, I focus on near term and the Earth.
Well, we had a good discussion before we came on stage about some of this, and the issue that in the military, I think the big thing we're looking at today is that the world is changing significantly in a lot of ways. Some areas that we don't in the military think of directly, like the things you're talking about, which are critical. But we do have a different world of threats, and those threats are, I would say, hybrid in some ways. And some of those threats have to do with natural resources. We've always had a little bit of a problem with that. We talked about oil earlier, but water becomes very critical. And if you look at, we talked about it a minute ago, in the Darfur, which is in the Sudan, have had a terrible conflict there, tribal versus farming people in the Darfur, all caused by conflict over land use for either grazing or for farming. And that's not going to be unique. That will become more and more common. And from a U.S. perspective, the U.S. military plans for things that could happen, not 100% would happen, but if it's a 50-50 shot, I mean, it makes sense for us to be, particularly if there's high risk involved with it. So you look at the Arctic, for example, which you all work on. The U.S. military now is paying attention to the Arctic because it's an open area of conflict, potentially. Hopefully it'd be peaceful use of the area. But when we do procurement of systems, boats, ships, icebreakers, that's a 30-year proposition. And you have to guess out into those areas. We also have to be ready for things we just didn't predict. And my contention is the U.S. military has never predicted one conflict right in the history of the world. So you never get it right. So you kind of got to plan across the spectrum. And the other thing that's probably a constant is the fact that you're going to respond to things you never guessed you would have. You look at the tsunami in the Pacific a few years ago, or even now.
Indonesia.
Indonesia, right. And even now with Nepal, I mean, the United States military is responding in a large way because we can, because we have huge mobility. And those natural disasters and water could be part of that.
You okay?
Sorry.
Good.
And but I'll just finish with this. The U.S. we're going to face a lot different threats in the future, in the near future. Our concern, I think, about water is that we're about 2030 away from probably a really serious crisis in the world on water. And
2030 mean the year 2030?
Yep, 2030. And if you look at the perspective of what that 2030 means, right now it seems like that's a ways off. We can probably figure it out. 9/11 was about 14 years ago. And I think that went just like that. So anyway, yes, we have a lot of issues that we have to start preparing for, and probably the only really military in the world that can do it because of size, and we do spend a lot of money as the U.S. military.
Kathy, aren't we just sort of one widget away from solving these water problems? It's just some spigot, salt water goes in one side, fresh water comes out the other. And why? So you say there'll be a catastrophe in 15 years. Why don't any of us have any hope or expectation that a clever person will show up and solve this problem so that water is no longer a strategic asset?
Well, there might be one widget, but there'll be 9 billion people by the year 2030 that Chuck's talking about. And so there are a number of factors. One is that widget takes electricity to run. And with the technology we currently have to
Or sunlight.
Or sunlight. But you're going to make water for 9 billion people. You're going to make water to irrigate an area the size of the Central Valley or some of the areas where TESS works. You're going to need some serious power density to make that all happen. So our widgets today that can take the salt out of seawater consume a lot of electricity to do that. And guess what? It takes a lot of water to produce a lot of electricity. So getting the economics to where you're really making some economic sense and getting the water cycle to where it's making some sense to suck in seawater to turn out a gallon of fresh water. And then, oh, by the way, since I do have that ocean word in our agency title, what's left when you've sucked the salt out of seawater is a really dense, salty brine. Okay, that just became your waste stream. What do you do with that? Well, you could put it back in the big ocean where it came from, except all the things that live in the big ocean, that 20% of the people depend on for food globally, they don't like really salty water like that. So there's the power density, there's the competing use of water for electricity and electricity to make water, there's the waste problem, and then there's just getting started improving some things to the appropriate scale and moving out on it. So one widget against 9 billion people is still a pretty tough proposition to scale.
Offline, we were talking about how much water it takes to make a bottle of water. Could you just share with us that?
Yeah, so when you buy a bottle of water, a little PET bottle of water, it took twice as much water to make the bottle as you have in the bottle. And depending how the water was filtered, assuming it actually was filtered and it's not just a fake label, depending how the filtering was done, it took 3 to 9 gallons of water to make 1 gallon of that bottled water, which then goes into plastic bottles that took twice as much water to make as they hold. So you got to get those scales and those efficiencies. And did any of you know that before right now? I didn't know it before.
Kathy, I'm never drinking water ever again in my life, now that you tell me this.
You know what? Municipal water is really fine. Anywhere in the United States, it's really fine.
It's really good, New York water. And of course, even in New York restaurants, they keep pushing bottled water on me when I said, no, whatever comes out of the WALD, that's what I'm drinking today.
You know, Penn and Teller did a social experiment one time where they created a wine bar. I think it was in Manhattan, actually, but it was a water bar. And they did a menu with all the different tasting things, and they wrote up all these, fancy descriptions about the aroma from the one from the Arctic. And of course, it being a TV show, they showed the waiters taking the empty water bottles to the garden hose in the back and filling them again. But all the patrons were like lock, stock, and barrel bought in on it. Oh, the nose is so good,
Tess, what do you guys use to clean water? You don't have devices, right? You just have wells and regional clear water lakes? Is that what's going on? You don't have technology helping you?
In the developing areas?
Yeah, where in your places?
Yeah, they're just pumping water right out of the ground or catching what they can in a barrel off their roof. Some places use certain types of filters, like you can build a clay filter that takes out a lot of the particulates, but you're left with biological activity that could still be a problem.
I like that, biological activity. It's a euphemism for like stuff that'll kill you, right? Is that?
Yeah.
NASA has a lot of scientists working on a lot of projects. Is there anybody trying to desalinate things? Is there anybody, if we're going to go to another planet and we want to live there, I'm told there's like water on the moon, right? How do you, if you're going to go there, you want to like clean it up so you can drink it. And presumably, astronauts in the space station, is it not true that they don't that they recycle their own urine and drink it? Is that correct?
We do. Right now on the space station, we
you don't. You're on Earth.
Okay, I'm on. We NASA.
Don't say we.
We
NASA. Good. Okay. Kathy drank her own pee. Is that right, Kathy?
That would be so not right. We made water from fuel cells on the space station.
From fuel cells. Okay. All right.
Up on the.
Damn, I thought I had that one. Okay.
Up on the ISS right now, we recycle about 85% of the water by purifying urine. To go to Mars, 8 months journey there, 8 months journey back, we're going to need to probably get to the point where we're recycling about 95% of the water. So we're not quite at the system that we'd like to be. So we're still
unless you find water on Mars and then you refill when you get there, like a water filling station.
Right, and we know there's water at the poles of the moon. We know there's water on Mars. So we have whole programs of research right now called In Situ Resource Utilization, or ISRU, because
we had an entire Asimov panel on that very subject.
So cool. you obviously, we need water to drink. We can't live very long without it. So that's one possible use of the water. But even more importantly, rocket fuel is basically made out of hydrogen and oxygen. So we want the water for the astronauts to drink potentially, but even more importantly, especially at Mars, we want that water to be turned into rocket fuel to help launch them up off the surface and get them home safely.
So, Ellen, as one of the folks that once upon a time thought she might be on the list that got to go do one of those things, the problem I had was there are not lakes on the moon that you just dip a bucket into. You've got to extract it from huge volumes of the surface material of the moon or Mars. So I never heard anyone talk too intelligently about what am I supposed to do from the time I land to the time that the other 700 rocket ships with all the supplies arrive to build the thing that will extract the water, to maybe make water. And if that doesn't work, then what are we doing?
That's a great question. It's something we're actually working on right now. We are working on a whole thing called the journey to Mars. How do you get humans to Mars in the 2030s, have them be able to land there safely, return home safely, and live for some period of time on the surface? So the idea is, and why we're working on these ISRU technologies so hard right now, is that you would pre-position an ISRU plant, say on the surface of Mars, somewhere near where the astronauts would be. You demonstrate that you can make rocket fuel. You demonstrate that you can do water before you ever send humans. So that's one of the reasons it's going to take us till the 2030s at least to get humans to Mars, because we have a lot of technology development, a lot of work to do to make sure there's resources on the surface of Mars by the time humans get there, or it wouldn't be viable. Mars isn't like sending humans to Antarctica or even to the IS, the International Space Station. It's a pretty harsh place. It's not a live off the land kind of place.
So you got to wonder if you can make that practical to do some of the work we need here on Earth.
Well, that's what I'm thinking the whole time.
Right.
You get the smartest people to solve the space-borne problem, and then you realize that has huge applications down here on
Absolutely.
Earth. That would be for people who might not necessarily have humanitarian blood flowing through them, but they like a really interesting engineering or science problem. And then they solve it for space, and then it comes back.
One of the problems we had in Afghanistan was, if you look at, most people probably paid a little attention to this, and there's this issue with IEDs, improvised explosive devices. They're all in convoy.
What are those again?
Improvised explosive device. It's
IEDs.
a made-up bomb that hits a vehicle and does bad things to it. 85% of our casualties in Afghanistan were in convoys. Those convoys were carrying water and fuel. The fuel to the battlefield is upwards to $400 a gallon, and they're using 22 gallons of fuel per soldier out there. Same thing with water issue, and some of that technology, we'll use it. It'll just be natural, but there'll be some things that are going to really help the human race come out of these things too. Bloom energy is one of them, for example.
Talking about some of the things we discussed before this, NASA usually does things in a one-off way. I mean, they'll come up with some great ideas and they'll do an amazing thing, but the word scalability is the words that you were using, both of you, earlier today. And certainly in the military world, that's something that you have to think about, as you just described. You're talking about supply lines. I think that's one of the disconnects that we might have if we tried to take a NASA thing and scale it up.
But I'm with Neil. I don't think you ask the guy who's trying to figure out how do you sustain people on Mars. I wouldn't ask that person, that guy, that gal to solve that problem too. Ask them to change the equation radically, and let the other smart folks say, oh, now that only costs 1/1000th of what it used to, look what I can do with it.
Right, and that's been the story of NASA. We estimate for about every dollar spent at NASA, about $4 gets returned to the U.S. economy, and that's through
like manna from heaven or something? What are you talking about?
Innovative new applications of technology.
The economic value of the innovations.
They'll grow.
I want to back up for a minute. Heidi, the astronauts went to the moon. There was no water there. So lately there's been this talk about water on the moon. How to get there and where is it and why?
The question of where's the water? Water is everywhere, but the problem is that it's in forms that are not easily accessible. For example, on the moon, as we were talking about, there's for sure water on the moon, but it's tightly bound up in clathrates, and you can't just get that water out.
Is clathrate some kind of, is that geo word for something?
Yeah, it's a geo word for like a mineral lattice, and then the water is trapped inside the lattice.
Oh, okay. So it's like a water bottle.
It's like
on a microscopic scale.
Okay,
yeah.
All right. So this is a point that was just made. The water may be there, but you need some kind of device where you dump in the stuff with water in the lattice and out comes a cup of water on the other side.
Yeah, much like we're talking about our desal techniques, right? When you've got the salt water going in and the fresh water coming out, except it's soil instead of salt water.
Now, Ellen, there are many people talking about the value of water in space, so that if you could go to a comet, extract water from it, and then deliver it to astronauts in space, then NASA doesn't have to launch the liter of water to get to them. Because that costs still how much a pound?
A lot.
To launch any amount of weight into space?
Yeah, it's
like
huge.
$10,000 a pound, right?
Yeah, it's a huge amount. So for us, we're always trying to minimize how much we have to launch off the surface of the Earth because we have all this gravity. So you need a big rocket to get things off the surface. That's why if you can find things out in the solar system and utilize them, all the better. Now, catching a comet, mining it for water, that's a bit difficult. It's a lot easier to go to Mars, where unlike the moon, water on Mars is probably much more accessible. We think there's probably ice under some of the dust on Mars. There's ice under the surface.
But I want to go to a comet. What's wrong with going to a comet? Why can't we do that?
I love comets.
We've gone to comets and...
no, but like lasso it and put it out in the thing and have and go get it when you need it. Put it in the Sudan so there's not a war going on.
Great. I can imagine that. We sort of targeted and, they did that experiment in Siberia or Russia not too long ago, right, when Chelyabinsk hit, right?
Oh, you're talking about in February 2013.
Exactly.
What do you mean? They unwittingly did the experiment.
Yeah,
okay.
nature did the experiment, delivering volatiles to us as comets or asteroids impacting our atmosphere.
There was an asteroid basically the size of this stage that collided with Earth at 40,000 miles an hour, exploded in air over the town of Chelyabinsk, injuring 1,600 people who all basically got cut by shattered glass because they saw this huge burst of light, and they all went running to the window to see what that was, forgetting their physics 101 that light travels faster than sound. And so they go to the window, then the shock wave hits, and then everyone gets cut. It was like the Band-Aid collision. But that's a collision with Earth. I'm talking about parking it somewhere and then drawing from it. Why is that so hard?
Well, I don't know, Neil. It sounds like science fiction to me, but, if we could think of a way to do that, sure. But, we're just working on recycling urine at this point.
Well, I must say...
Okay, well, get back to work on that then. What, Ellen?
We do have a plan to go get a piece of an asteroid and bring it back to the vicinity of the moon. It's called the Asteroid Retrieval Mission that NASA's working on right now to do in the 2020s, which would go get a piece of an asteroid and bring it back.
So kind of test of concept then.
You could say that. And asteroids actually have a lot of water. In fact, some scientists think that it was actually asteroids that delivered most of our water to the Earth, not comets.
This is that lattice water that you've been talking about.
Exactly.
I always wondered, I look at an asteroid, it's just like a dead rock to me. And then the geologists get all excited that it has water. Excuse me.
We're actually finding asteroids now in the main belt that have tails and commi like comets. And so they call them main belt comets, but they're asteroids. So let's just get a little terminology here straight. An asteroid is a dirt ball with some ice mixed in, and a comet is an ice ball with some dirt mixed in. And so,
that's the kind of lingo I'm looking for here. Thank you, Heidi. Okay.
But there's some challenges with comets that are a bit distinct from asteroids. And one of the challenges is that most of the comets that we have visited now with NASA spacecraft, with ESA spacecraft,
European Space Agency,
they tend to be somewhat fluffier. They are icy, and so their tensile strength is lower. So it's a little bit more challenging, I think, to think about towing one back, because comets often just fall apart on their own. I mean, just sunlight makes it fall apart.
So they don't have much structural integrity to go reach out and grabbing it and putting it one place or another.
That's right.
This is the problem, you're saying?
It could be a problem, yeah.
Towing your snow cone.
That would be hard,
yeah,
to tow a snow cone. Okay.
So why don't we tow icebergs? I actually wanted to ask our water resource person, why don't we have Alaska. There's a lot of ice up there. Can't we get some big chunks of it and tow them down to California?
Wait, just a sec. Weren't there plans in previous wars to move icebergs around as a source of water?
They've already done it.
They've already done it. Excuse me, I'm late in the coming here. Okay.
No, I'm learning more stuff about comets and asteroids. This is amazing, really.
Excuse me, I want to know what the military did moving icebergs around. We'll get back to them in a minute.
Saudi Arabia purchased an iceberg. And they were going to bring it to Saudi Arabia. No, they never did it, but they did.
Wait. Who sold them the iceberg? That's what I want to know. I will get in on that one right here.
I think it was Noah.
You attach an iceberg to some ship and drag it somewhere.
Right.
And then what happens?
Melt it and use it.
Okay, then. So, Tess, what?
Well, so the issue with that, and the same with the desal, is that
Desalinization?
Desalinization.
So you're like a nickname basis with the technology.
Yeah.
Desal. Okay, go. Uh-huh.
Is that you're only providing water right at the coast. And like if you think about the US, where most of our agriculture is, you would have to cross a mountain range to get to Central California and half the country to get to the high plains. And so moving that water requires more energy than it would take to desalinate, which is our initial problem. And so we need to think about more than how do we provide drinking water to the people on the coast, but how do we provide water for all the agriculture and building our clothes and electronics and all that stuff.
You know, there's some semi-good news. I mean,
okay, let me hear.
The kind of the bad news is that, again, between now and 2050, the urbanization of the littoral, the coastlines of the world is going to grow dramatically. That's where people are going to move to. And so there is a transportation issue. I get it. But
just to be clear, you're saying this trend has been going on, in fact, for the entire 20th century,
Yep.
where cities are becoming more populated relative to rural and suburban communities.
yeah, absolutely.
Okay.
Absolutely. And you've read all the size of the cities. The Marine Corps, matter of fact, their major strategy for the future is urban warfare along the littoral. But
Along the what?
the littoral, the coastline, the littoral of.
What is that word? That's a new word for me. What is
Really?
it? Say it
Is
again.
that a military word? Littoral?
No, that's a
Littoral.
science word.
Am I the only one?
Science word.
It's a science word?
It's a science word.
I'm sorry.
It's Neil, it's an
Have you
earth
heard of
science.
this word before? Littoral? Or is it just me? I don't know. No,
It's an earth science word.
Earth science. Oh, tell me. What? Just. I'll get back to you in a minute. Let me get this word defined. Go.
Coastal zones, the coastlines and shallow seas fringing the coasts.
Would that include being on a coast if you're on a river?
Well-
It's about being on the coast of the sea.
Yeah.
Of the seas
Of
and the
the sea,
oceans.
yep.
Okay, fine. Littoral. Thank you.
I thought that was a common.
No, I'm sorry.
I mean,
Sorry.
but desalination or icebergs, impractical, but could be. So this is more than a one solution issue, right? I mean, I think so. That could be part of it. And moving the water inland is very problematic. But talking to some friends I have that work with U.S. Water and other areas, the big push they say is a couple of things in the near term, not long term. I think long term is going to be some space solution of some sort, no doubt about it, in a lot of ways. But I think in the near term, it's going to be a realization that water is costs, which has always been a kind of a moral issue. And number two is we're going to have to use wastewater and recycle everything we have.
So Neil,
Yeah.
we're worried about getting drinkable water. And in this country, we use drinkable water for our lawns and our laundry and our toilets. The biggest water treatment plant in Southern California pumps trillions of gallons of treated water that's drinkable standards, except it'd probably offend us all, pump it into the sea because it's been treated and because we built our system to be one way. That could probably water all the lawns in Southern California, that could do all the laundry, that could power plants, but we just dump it into the ocean. So before we go doing widgets and gadgets, we might want to look at how we're using what we got.
Okay, so, yeah, okay, so what comes first? Thinking of water as a strategic, potable water as a strategic asset because we're running low on it, or interfacing with the different stages of cleanliness of the water in a more intelligent way? At what point do you say, I don't want to do that, and I want to fight a war to get access to clean water, or do you turn the problem back inland and say, let's fix how we've ever intersected with our own usage of water, be it for watering plants, cleaning clothes, drinking, or taking a shower?
I think you have to make water a holistic issue. And right now, it's in businesses a lot of times, it has to do just purely with a bottom line, which is, it's a motivation, there's no doubt about it. But I think it has to be much more sophisticated, it has to be more holistic, and it has to be done fairly quickly. I mean, we were talking earlier about the Gaza, which last summer the Israelis...
By the way, when everyone here has been saying, we were talking earlier, we just had a mini press conference with 7 members of the press, and so a lot of this came up then. This is the referencing to earlier.
Right.
It's not like something that you missed that you wondering what we. That's so. Continue.
But I like your questions better than the press. I mean, but in the Gaza, as we all know, that's a size of Washington D.C. that's very structured. It's people are closed in, and water is of the essence. They live on the water, but they don't have a desal plant there, right? They get their water from Israel. And they're using so much water that in 2 years, the aquifer is going to desalinate, and they won't have any water. Now, that's going to be a crisis, in the making right there. And we talk about what
you see that coming already.
You see it coming.
And so.
Well, but I'd like to bring it back to California. I mean, certainly, and this is where I think the U.S.
You're from California, right?
I used to live in California because I worked at the Jet Propulsion Laboratory out there for a while.
In Pasadena, California.
Right. And I guess to me, the frustration I see is this is such an opportunity for us to lead, because we look at the situation in California right now that is suffering a severe drought. They're pumping out their aquifer to grow food for all of us in the Central Valley of California that we all eat. So if you think, well, it's California's problem, it's not my problem, it's all of our problem. That's where our food comes from. And there's a real issue. Reduced because of the drought, less snowpack, less water, it's not recharging the aquifer, it's not refilling the reservoirs. So we're in a crisis right here, and it's consistent with climate change. These mega droughts like we're seeing in the Southwest is consistent with climate change. So we have to start valuing water as a precious, finite commodity here. And face it, we have the technology, we have the know-how to lead the rest of the world, but we need to do it.
So
Can I
have a question? How can we turn that plant around so that water's not being thrown away? And, who makes that choice? Is it our choice? Can we write petitions?
Do you, as head of NOAA, suggest that on TV to the rest of the world? The way the Surgeon General used to get up there and tell America how stuff went down.
Yeah, there is the bully pulpit sort of power of the pulpit opportunity, certainly. So water management in the United States is sort of one step up above the Surgeon General. It tends to be municipal and state controlled. Mm-hmm. So it's not federal controlled. It's not federal regulated, and it's not even really, most of the data about water usage in the US is actually state and local data. A lot of the many thousands of wells in the country are not listed anywhere. We don't know what the real count is, and they're not metered, so you don't really know the usage. So that plant in Southern California, built back when it was built, is in the very southern part of the LA area, mainly because you wanted it out of your way. It's an unsightly thing, so they put it out where people didn't live at the time. And that's actually slightly downhill. Boy, you wish it wasn't at this point, because now to turn that plumbing around and be able to reuse some of that water would be tremendous. Vegas has had to do this for years. The big resorts with all their fountains are all closed loop, not using any fresh water.
What's that information you gave us about the per capita consumption of water in Vegas compared with New Yorkers?
Yeah, the per capita consumption of water in Las Vegas, the number is from a couple of years ago, probably still very close to true. Twice the per capita consumption of water as you have here in New York, but it rains 10 times as much rain in New York. Let me pick up on the point that both Tess and Ellen have made too, with another little piece. Agriculture is the biggest use of water in Nevada. It's like 90% of Nevada's water use. The agricultural sector in Nevada employs about 6,000 people. The Mirage Hotel, singular, in Vegas employs more people than that. So there are all these odd, scale factors.
So what's going on? So tying this, the Colorado River, I've read that, or any river, consider it. The river has fresh water because it's basically rainwater collecting into a basin and finding its way to the ocean, where it's salty there. And so I have a river adjacent to my town, my county, my state, and I start taking water from the river. I can do it directly from the river or from my aquifer, which feeds the river. Isn't that correct? If I understand the little bit of geology that I know. If that's the case, you're downstream from me. The river now has less water in it because I sucked it out and used it for my agriculture, and you're a different state. Is this the beginnings of state warfare? And eventually, what is the flow rate of that river 10 states down the line? And isn't this actually happening?
Yeah, why are you saying this in a hypothetical way?
So Des Moines, the Des Moines, Iowa Municipal Utility is in the process of suing 3 upstream counties for failure to manage their feeder system off the farmlands that's dumping too much nitrate into the Raccoon River that feeds Des Moines municipal water. Think Darfur, farmers upland, urban users downland. You're doing something to the water that's affecting my ability to use the water. It's happening in 35 states in this country are fighting with each other over water today.
No, I mean, you go to California, the whole Colorado River, but I was just in Ethiopia a couple weeks ago, and they're building a huge dam on the Nile. The Nile actually, flows toward the Mediterranean, obviously into Egypt. And it's a big issue with Egypt. I mean, they've threatened war over this thing because so they're going to have to accommodate how much are they going to take out, but but they're going to keep it for electricity actually. But they're stopping the water, and that's the future. I mean, that's what Israel's had an issue with the river, the Jordan River, and all that for a long time. And that's not so water wars are not. First of all, they're not new, but they could be exacerbated, I think.
What's going on? Is something in Syria going on related to water as well?
Well, they had a dam there in Syria at Mosul, or the dam that went from Mosul down into Iraq, and the ISIS folks took it over. They got it back. Okay. We used to fly over it. But again, you're talking about water distribution into Iraq, which again has a huge morality issue to it, has a huge strategic issue, a lot of influence, and so those are, people will do, we've seen this in the Middle East with some of the activity on there, going there. There is no morality to the war there, I mean, in some cases. And water certainly is a target, so.
That's just an interesting sentence. There's no morality in that war. I don't, just interesting.
Well, no, I said that war there.
Oh, war there, no, just.
Yeah. Well, no, wait a second.
No, I was just.
No, you're right. Okay, Freudian slip.
No, that's fine.
I'm a military guy. Everything's a nail, I'm a hammer.
Yeah, I got you. And we expect that. This is why that you exist. Tess, let me ask. I don't really understand aquifers. And I'm just wondering, I saw a map that compared, was it 10 years ago or 20 years ago, the volume of aquifer water in California relative to today. Was it lower or less, or where did it go? Why isn't it there? And could you just give me like Aquifer 101? Plus, if we're going to find life on Mars, isn't it going to be in an aquifer beneath the soils? Because on the surface, you wouldn't expect that. So could you just give me a 101 on this?
Sure. Aquifers are groundwater. So when you drill a well, you're drilling into an aquifer. And an aquifer, by definition, means that it can provide enough water to be useful. It's basically like if my cup were full of sand, the part that the water goes up to is the aquifer. It's filling all the pore spaces in between the sediments, in the rock, fractures, and
okay.
What else did you say?
Okay, that's Aquifer 101.
Yeah.
So,
the California.
Yeah, so California, is that, so what's going on? So, because my naive thought is, there's water in the ground, I take out the water, I water the plant, and the plant uses some of it, but the rest goes in the soil, and doesn't it go back to the aquifer? And I pull out of the well, and I drink it, and then I pee later, and it goes back in. Where's the water going? I thought it was all just one cycle.
So that's what the farmers in India that I work with think. It's okay to overwater my field because the rest of it just goes back to the aquifer. But we have to remember the other thing that's happening, right? Evaporation.
But that goes to a cloud that then rains later.
Right, but the time that it takes the water to go back into the aquifer is longer than it takes you to pump it. And so...
so it's out of equilibrium.
Yes.
Oh.
Yeah. Yeah.
That's different.
And so there are aquifers that are in equilibrium and that we're pumping at a reasonable, sustainable rate, and those are fine. And then there's ones that we're pumping faster than recharge goes back in. We're actually pumping water that recharged in a previous ice age.
Whoa.
Yeah.
Okay, so why isn't that causing earthquakes?
Why is it? Or
is it not?
It is in some places.
Oh, okay, that's the answer. Good, all right.
It's causing massive land subsidence in some places.
Yeah.
You can find telephone poles in the Imperial Valley of California where people would put a sign on the ground and take a picture of it, and they come back 10 years later, and that sign is here, and it's like 100 feet of subsidence from pulling the groundwater out.
Well, I missed the sense of where the sign was. So the sign was high and then it was low?
You put a sign on the ground, you come back 10 years later, because the land sank, the sign is now 10 feet above the current ground
the
level.
land sank.
The land sank. So you put another sign, you come back another 10 years, and there's like 100 foot of subsidence.
Oh,
from
because I
water
was just
withdrawal.
in Venice, and they have really too much water there. Venice, Italy, and like everything's just sinking. And you know, you're walking on a floor, and they said this is the floor of the last centuries, but 4 centuries ago the floor was 5 feet below you, and so everything's just sinking, returning to the earth.
But the other thing is, it's in California, it's sinking, but it's also rising because they're pumping all this water out of the ground, which makes it lighter. And then, so that crust material that's floating on our mantle is now lighter, and so it is more buoyant and it floats up a little bit. And that's what's causing the earthquakes that people have been talking about in California.
Oh.
So
that's
it's actually,
complicated.
yeah, it's coming up and it's releasing the pressure on parts of the San Andreas, and so it makes it easier to see.
So what I'm hearing is the word disequilibrium, and that sounds like a pretty important word here for water usage, for just how people are interacting with our planet right now, is that we're kind of driving it into disequilibrium by where the people are going and how much of the resources they're using. But we're not actively trying to mitigate it yet. What will it take?
But nobody's thinking about equilibrium here, right? It's not a thought. We don't know. But I'm still in the aquifer thing here. Before I flesh that out some more, if we're going to find life on Mars, it's going to be in an aquifer. Why do you think there are aquifers on Mars?
Well, we have a lot of good reasons for thinking that when we take our rovers there and we look at the geology, we can see
Marsology.
Mars geology.
Geo means Earth, I'm just saying.
The marology.
The marology, yeah. That word sucks. Okay, stick with geology, I got you. Okay, I'm with you.
We look at the rocks. When we look at the rocks, we see layers in the rocks. And the layers in the rocks tell us that at times there could be standing water. It's not just layers. There's also structures that we see, small-scale structures that we know from studies to Earth that must have formed in standing water. There's chemistry. There's chemistry we see that we know is indicative of water in the past. And so there are many lines of evidence from the spacecraft we've sent there that tell us that water is there. But we know it's not on the surface now. It's dry on the surface now, dry as a bone. However, we do know when some of the spacecraft have scooped up soil, and when they look at it initially, it's very white and reflective. And so we know that and then it dissipates, it sublimes, it evaporates, it's gone. Mm-hmm. So it's this strong evidence that there is water ice underneath the surface.
Okay, but it's frozen, it's not liquid then.
Oh, it's probably not liquid, though.
Okay, so you wouldn't expect life as we know it to thriving in ice.
Not right now, maybe in the past, though. I think as Ellen said, we aren't looking for plants and little green men and women. We're looking for the traces of biological activity in the past.
Yeah, so we're mostly looking for fossilized life, fossil evidence of life.
Evidence of life having once thrived.
Exactly. Though there are people who believe that, scientists who think that life could have gone underground, so that if you did pump water from deep enough, because if you go deep enough down, it actually gets warmer as you go deeper into a planet.
Is that true in Mars as well?
Yeah. Mm-hmm.
Oh, so there'd be a point where you've liquefied.
Yes. Yeah, there should be actually a water table deep in Mars.
I didn't know that.
If you drilled down to that.
About how far?
A couple kilometers down. So
that's all.
We don't have the technology right now to drill that deep, but you actually have to get a couple meters below the surface on Mars to get away from the radiation. There's solar radiation and cosmic radiation because Mars doesn't have a protective magnetic field anymore. It used to in the past, it doesn't now. And so the surface of Mars
This would be
is
radiation that's hostile to life, to the molecules that comprise life.
As we know it. But on the other hand,
if we were all tardigrades, this would not be a problem.
Exactly.
The little water bears.
The little water bears.
The cutie
they're
little.
So cute.
You ever see the tardigrades? They're the cutest. They're like this big, And you could like step on them and they'll survive.
But
Like
they look like little
radiate
bears.
them, squeeze them, heat them, freeze dry. Did I leave it, microwave them? Did I leave anything out?
Pretty much, they'll live through anything. Take them into space.
Yeah.
They live. So, and that's one of the things, that's what makes us so optimistic about finding life off the Earth, because what we've learned over the last 10 to 20 years is we found life in the oddest places here on Earth. Extreme cold, extreme hot. Life lives there's bacteria that live in radioactive waste. So life is very tenacious, and that's why we wonder, could that life on Mars have migrated to a point where there is still? And that's something we worry about for exploring Mars, because certainly we wouldn't want to bring that back to Earth.
Sure seems like we get a little trifle mixed up here a little bit.
What's that? Tell me. Straighten me out.
I mean, first of all, I love what you guys are doing, and I think, that's what America should do and the world should do. We should explore and find out, and who knows, we have to go live there someday is the point, I guess. In the near term, you were talking about, why don't we do something, right, in the Earth? And it's an amazing thing, because, I mean, you just can't get people to have consensus around the world. I mean, it's like in America, okay, we'll give up half our water for somebody else. I don't think so. I mean, and so you have this really interesting dynamic in the world right now. We talked again previously with the, sorry, but this dynamic where you almost have to have, unfortunately, a crisis, I think.
The crisis would have to be, I turn on my tap and the water doesn't come.
Yeah, or you get real thirsty and you die, and
Yeah, that
but there are places that they spend their whole day trying to get water. I mean, and,
just to be clear, you can go a month without food, but you're dead in 10 days without water.
Right.
Is that about fair?
if you're lucky to go 10.
Yeah, if you're lucky, right.
So I guess my real question there, since there was a question embedded, what are we doing about all the cool things you guys are doing? I mean, really tremendously cool. I get fired up hearing about it, to make life on Earth better.
Well, everything we do at NASA, we feel comes back to the Earth, whether it's through technology, whether it's through the direct research we do with our 19 satellites that we do with our partners at NOAA and our international partners to measure all these things, to try to figure out what's happening on the Earth right now, because climate change is happening right now. There are streets in Florida that flood at high tide, mega drought in California. The Arctic ice is melting. Come on, people, what more do you need? Climate change is happening.
You're in New York here, that's fine. We already get it. Okay. We got that, right, all right.
So, certainly we're working on that, but the amazing thing is all of this research we do, whether it's the health research we do on the astronauts up on the International Space Station, a lot of that we bring back to help people right here on Earth. All this technology ultimately helps our own planet.
So the trick is, this has been principally a scientific conversation. It's, as you know, Chuck, just within the last not that many years, it began to be a national security conversation, and it's really only just starting to become an economic conversation. I remarked in our earlier session, the great line that characterized this part of the issue to me was, guess who? Stephen Colbert, who said, hey, if my body is 60% water, how come I'm only 2% interested? So, and you know what? The reason is because it comes out of the wall, and it's essentially free to you right now.
Comes out
so
of the wall.
It's just it's the taken for granted routine, and since you only have 10 days to get seriously worried about it when you hit a wall, it's going to get really ugly when you hit a wall. This is not going to be sitting quietly in your living room until you pass away. This is going to fray society.
But strategically here, suppose there's water elsewhere in the world, and somehow we run out of water here. That becomes a strategic asset, presumably no different than oil. We'll start having federal governmental policy related to the acquisition and the protection of that asset. My question to you is, as was discussed earlier, you could bring some fresh water now you have to bring it inland and take it to the crops, and the distribution of it is a whole other frontier than just simply getting access to it in the first place.
I think there's a dynamic about water that it's hard to even imagine the emotion of it, but I think all of us here would probably do something pretty drastic if we didn't have water and somebody else did. That's a terrible thing to think about. I mean, and that would be.
Yeah, but you're paid to think about that.
Well, And I think people do horrible things when they're pressured. And you know, so again, I mean, this is one of those things where we talked about energy a little bit and oil. You could probably work around that somehow. You could probably live, you know, if it was totally cut off, wouldn't work very good. But if you start cutting off water, this is like people, you know, Maslow's theory here. I want my air, I want my water, and then everything else after that's gravy, kind of. And
Who's
Maslow, you know, Maslow's theory of hierarchy.
I'm sorry, we must be reading different books.
Oh.
But that's a very sensible philosophy. I need my air, I need my water.
Yeah.
After that, life is gravy.
Air, water, food, clothing, shelter, those are the priorities, right?
Okay.
And we're all living
Sex
pretty good.
is in there too for the species. We need that.
That's it's there.
Yeah.
And but the problem, you talk about these problems where in times when we got plenty of water here, life is good for us mostly, and we're not really, I mean, we can gripe about things that are happening in America, but you go around the world, there's some problems out there, and water will be an exacerbator, no doubt about it, in a big way.
So so you don't really have any hope for the situation?
No, absolutely have hope because...
Yeah, where you, in fact...
Here's where you have hope.
We have to sort of bring this to closure. I want to hear where everyone's got some hope. By the way, I try not to have hope because it implies that I want an outcome for which I have no control over it. And so I'd rather think about things I can affect, and then you don't have to hope for it, you can make the change. So that's just my relationship to the word hope. Is there...
I love Churchill's line.
What's
You've heard
that?
it, right? America gets it right every time after eliminating every other possible solution. So I think it's going to be it'll be a pressure issue.
Okay, so this came up earlier. We're going to have to be up against the wall, hitting bottom, whatever is the metaphor, then we'll respond in some way that will sensibly solve this problem. That's what you're thinking?
Yes.
Okay.
I'd hate to say it, but...
Yeah, no, we pay you to be real. That's what that is.
That's a good point.
Yeah, okay. Kathy, as head of NOAA, don't just tell us what's going wrong, fix it. Well, are you in the solution business or telling us what's wrong business?
I think we're in the solution business.
I don't-
We certainly have the science data that paints the landscape, that describes the issue. But going back to our roots to make this information matter and make it connect to real world decisions. So I get some hope because I think these kinds of issues and the sensitivities and the risks they pose to society, to humankind, are beginning to connect to the economic world that we live in. And I think that I agree with Chuck. Pressure points that become really demanding is one way this gets solved. Economic signals is another way to change the equation on with what speed are we acting about this. So the Bloomberg trading terminals, my meeting before this event was with guys from Bloomberg today. They've incorporated water scarcity into
Bloomberg Financial Markets.
The Bloomberg Financial Markets and their business information circuit. So folks that are in investment banking, or they're doing big construction projects, or they're doing mining, or they're citing another business, you can now overlay and say, hey, this takes X gallons of water to do your business process, and you think you're putting it there. That's nuts. It's too risky for your business decision. It's too risky for me to finance you. It's too risky for me to insure you.
Because the data contains the content in the aquifer from which it's drawing water.
It contains a total picture of total water scarcity and water. Look, water stress can be the availability of the resource. It can be political instability. It can be regulatory uncertainty. All those things go to how reliable is that water supply that you're...
That's a new feature in your capacity to make a business decision on the Bloomberg terminal.
If it starts to change how the big economic drivers of our world are shaping their decisions, I think is a second pathway for it to start entering social decision-making and policy decisions.
So my wife told me earlier that she thinks that just a way to solve this is make sure everything costs exactly what it actually costs.
Make sure it costs anything close to anything above zero would be a good thing in water.
And then people will think about how they're using water.
You'll start weighing that against other things that are important to you. And you find out that, hey, you know what, if I use this water twice, once for my dishes and once through a filter to put it on my lawn, it saves me $10,000 a year? Yeah.
People do it like that.
Yeah. And they can do the equation that says, hey, that's worth the $500 water filter that otherwise I probably wouldn't bother with.
The key phrase there is, they can do the equation? Is that what you're assuming?
People can
This is
do
America we're talking about.
Yeah, they can do their household consumer budget.
Okay, if they could do the equation with home mortgages, we wouldn't have, you know. They can do the equation as a big step, I think. Tess.
Yeah.
You study these problems, but what are your solutions?
Well, so I'm working on a number of solutions, but I agree with Chuck that we're going to have to like hit the wall before people are taking action on this. But the good thing about that is that hydrology is really local, so that people are hitting the wall already in certain places, and it's not catastrophic, but farmers in certain parts of Texas and certain parts of Kansas are already making decisions about how to better manage their farms and what technology they should be adopting.
So
and it's
not
just
everyone is hitting the wall at the same time.
Exactly. So you have a little bit of time. It's not just 10 days to die. It's like your neighbor's going to start adopting something because his well goes dry first, and then it'll spread. That's what I think. So there's a bit of hope.
Okay. And what is we can say it and we want it to be true, but we kind of have to wait till we see it to then agree with you that all this investment in high technology made by NASA applies back to Earth eventually. So is there any focusing of this expenditure where we can then say, yeah, I'm going to wait, that's going to be a good one. That's going to help. Let's keep an eye on that one.
You know, you don't have to wait. That's the good news. Because, for example, just a couple months ago, we launched a satellite called the Soil Moisture Active-Passive mission. That's getting data on what fields are wet, what fields are dry, what regions are wet, what regions are dry. That's just one of the many sensors.
Wait, this is a satellite that's monitoring crops.
It's monitoring the ground to help understand not just weather and climate, but to help farmers make decisions about crops. That's just one of the many satellites that we have working again with NOAA, with USGS.
Is that because farmers have been overwatering crops, for example? Is that a problem?
Yeah, because if they don't know, if they think, well, I don't know if the field.
Doesn't a farmer know when the corn needs water?
They know, but they can get it to a much more precise level. There's an incredible amount of water in agriculture that's actually wasted. And so if you can fine-tune the amount of water you make, you actually make a huge difference. We have that technology. Working with all our partner agencies, we're gathering it. And I think what Kathy was alluding to even more importantly, there's people who now see economic value. This isn't just data for scientists. It's information that a company says, well, I can work with farmers and actually make money off of this. And that's what I hope is going to drive a lot of the change, is when the private sector says, there's money to be made in that data. It helps all of us. It becomes a virtuous circle. We start using less water. We still are growing crops to feed the world. And we're all better off. And we're not just doing this. We're not just providing this in the US to our own farmers. We're doing it for farmers around the world. Kathy's agency and NASA work together through multiple programs to help farmers, to help scientists around the world use this data, so it's not just the US benefiting from it.
Just, Kath, before I get to back to Heidi here. Kathy, what % of all fresh water is used for crops?
So the total fresh water on the planet is about 2.5% of the total water. The rest is salt and other things.
It's only 2.5%?
It's only about 2.5%, and only about 0.4% of the total water on Earth is the drinkable, usable water, and 90% roughly globally of that is used for agriculture.
Okay, so
we're living on less than 0.5% of the total water on the planet.
Okay, so let me just get your percentages in the right sequence here. So 2.5% is the total amount of water we're talking about right now.
Fresh water.
Of the 2.5% that is fresh water, 90% of that is used for agriculture.
Basically, yes.
So the remaining 10% of 2.5%.
Wait, correction, friendly amendment.
Busted, okay. All right, Tess, what do you have?
Get it right, Tess.
No, so the 2.5% is the fresh water. Yeah. 2/3 of that is in ice caps. 1/3 is underground.
Busted, okay. Ice caps.
What
right.
she said.
Okay. Okay,
But
I was asking the wrong person.
No, but
Tess!
Kathy was right. About 70 to 90% of the fresh water consumed in the world goes to agriculture. So
Okay, could there be a day, if it all goes to agriculture, could there be a day where we no longer drink water, that our water is completely consumed via the water content of our food?
Oh, now you're asking physiology questions?
Yeah, I don't know.
You don't have the right people on this panel.
Okay, sorry, all right, I'm just wondering.
I don't know. Oranges, coconut water?
Yeah, I don't know, yeah.
Watermelon has a lot of water.
Yeah, it does. All right, coconut water, yeah. We'll solve this problem. Before the night's over. So Heidi, I know you don't like build machines like such as this, and you think about water in the solar system. Do you have any really long-term thoughts about how we might use the water that's out there, or is it really just sort of an exploratory frontier for you without the practical application?
So the exploration of the solar system I see as science and engineering. That's what we do at NASA. We do science and engineering. And I ask the question, what do you need to solve these problems that you're talking about? You need young people who are educated in science and engineering. And so it seems to me that there is a natural connection. And I don't mean that just because I get a lot of my funding from NASA. There's actually economic studies of engineers. And they, Forbes had a survey of engineers, thousands of engineers. And they asked, what's your dream job? And they all said, many, I think it was something like 70% said, working for NASA. Now, these are not engineers that actually build spacecraft. These are petroleum engineers and engineers who are developing automotive systems and all kinds of engineers. But NASA is what's inspiring them. So I view what we do as bringing that into the equation. Somewhere out there right now, there is a little girl. And in about 20 years, right about the time scale you're talking about, that we need someone to help solve these problems, she's going to be there. But she's going to her school library right now, and I guarantee you she is not getting a book about desal. All right? She isn't.
Yeah, I'm with you on that.
And she's probably not going to be studying aquifers. She's not looking at resource utilization. And I know these things because I have kids and I've worked in their libraries. They're getting out books about black holes, which are just as esoteric as those other things, but kids love that. So NASA plays a very important role for our country, inspiring people, inspiring kids. I mean, I just, the kind of stuff that...
This is where the music comes in, as you...
So sorry I don't have the answers, but I'm trying to get the people out there who will have the answers.
Yeah, I got to agree entirely with Heidi on that, because the universe is quite the force of attraction for kids in middle school and high school. Kind of a gateway science, if you will, to think of... You know I'm right. You just know.
Hey, I was one.
Okay, all right. We only have a couple more minutes here. General, let me ask you a question. Do you really foresee wars over water going forward? I mean, are your people who are still at the Pentagon, are there whole situation rooms where they're plotting what kind of war would occur in the presence of scarcity of water? Is that?
No, I mean, yeah, I mean.
Okay.
So it isn't the type of war it would be. It is a war, right? So
what you're saying is it's a strategic resource.
Absolutely.
Therefore, and.
So I think there's a high likelihood, unless something changes, there will be serious conflict over water in not too distant future, 15, 30 years. Maybe before that. And I think there's already been conflicts over water.
Yeah.
In different ways, but yeah.
That's what I was just going to say. There's some convincing evidence that Libya and Syria and the unrest there has got an underpinning of water stress and disruption.
Okay, I know I asked that question, but I'm going to go back to Heidi for a happy thought to end, to end the evening on. I know I asked for that, but I'm trying to get a happy thought here. Do you see this movement into attracting kids into space sciences as, could it really be the solution to all our problems, especially since space has unlimited resources and unlimited energy? Would you agree?
Well, yes. I don't think the movement is to get kids into space sciences. The movement is to get people thinking scientifically and appreciating science, appreciating engineering. And they don't need to be astronomers. They don't need to be space scientists, but they need to be educated people. That's the goal.
Ladies and gentlemen, let's thank our panel. I think, Heidi, you could end any panel on that. We need to be educated. That's what that is. If we bring up the lights a little bit, and we're going to take some questions. I think we actually have the question microphones up here on stage. So if you walk up, I can hand the mic down. And then we take questions of the panel. We do have a microphone right here. Is it live? It's going to be in a moment. So you can come on up, and I don't know if we'll have a second one on this aisle. We'll spend about 10 minutes in Q&A, just so we can hear what you're thinking about what just unfolded. Why don't we start here? Why don't someone come on down, and I'll hand you my microphone. Come here. Okay, go.
Okay, so a lot of the panelists were saying how America has to lead the world, but how are we bringing these developing countries who don't necessarily have the resources to maybe follow in this technological path, how are we bringing them on board into something that requires this long-term investment?
Wait, how old are you?
13, Mr. Tyson. Wow.
Okay, whatever you're doing, keep doing it, all right? Yeah, sure.
I just got back a couple weeks ago from South Africa, where I was speaking at a science festival for kids that about 70,000 kids came through. And I was working with the Ministry of Science and Technology in South Africa, and they said their principal focus right now is human capital development. How can we get our citizens, we talk about STEM education, the importance of having STEM education.
STEM, science, technology, engineering, and math.
And countries that I visit around the world, that's a huge focus. They love to have people from NASA come because we have a great brand, and we actually get kids excited, not just in the US, but all around the world. So countries understand this. And then we have programs. We work with NASA. We work with the US Agency for International Development. This one program we have called SERVIR, where we go, and again, we take our data, we help scientists, engineers in those countries, in countries that are really struggling, how to use this data. So we're not just throwing it over the transom and saying, good luck, world. We're actually out there working with people. NOAA does this, NASA does it. It's really important that we actually get out there and help people use our data.
And she led off with the fact that a big piece of this is the intellectual capital as well.
Let me go back to the question though, as far why is it only the United States? Are we the only people that can lead, whatever the No, but we need we need to provide leadership. But if you look at our foreign aid budget, for example, you talk about how do you make other countries help themselves. Our theory when I was in European Command, we had Africa in our area of responsibility, was help them help themselves. Not lead for them, not do that for them, help them become self-sufficient. Our foreign aid budget is, most people, take a guess, what do you think our foreign aid budget is?
Every time I hear it, it always was lower than I thought it would have been or should have been.
1%.
1% of the federal budget.
1% of the federal budget. We put $40-some billion a year into foreign aid. And the amount of ability for countries to take care of themselves, to be more stable, which is really what we're looking for. Our job in the military is to get out of the business.
Exactly.
And so, yes, 100%. We should do more and more of that. And by the way, none of these problems are ever going to be solved by the United States alone, ever. It's going to have to be a global issue. So That's your job.
You go forth and do this. But you briefly mentioned something that's a famous, is it adage or an epithet? The ultimate task of a general is to lay down his sword.
Absolutely.
Yeah. Put yourself out of business. Yes, over here. Go.
Okay, you're talking about, is this coming through?
Yeah.
Yeah,
Okay.
yeah.
Okay, you're talking about the water shortage, which is really aggravated by global warming. Most scientists agree, or actually nearly every of them agree that it's real, that you get politicians who are ignoring it and actively denying it. It's like they were being paid off by the fossil fuel industries. Why is there such a controversy about the occurrence of global warming? What is preventing people from realizing how real it is?
I'll take a shot at that.
Okay, go.
Two-prong answer. One is, it is such a massive disruptor, the human inclination to really want proof positive, which means you're going to wait too long. But there's another dimension to this question. Change is happening. It's clear in the data. It's clear on the ground. NOAA has an agreement, for example, with the Western Governors Association centered on water and water data. So these same folks will ask me when I come talk with them to please not say the C word, but they also know their ranchers and their farmers and their municipal water managers are seeing changes now. They know that they can't, the statistics, as Neil said before, the patterns they were used to that worked for decades when they built their businesses or built their water system, those patterns are falling apart because the patterns are changing. And that's real, it's being seen, and that's becoming part of what's undoing slowly the political backlash against accepting human forcing. Look,
The Pope just talked about climate change today, I think. Is that
well, and look, whether it's the planet itself or I did it or you did it or God did it or whatever, if the patterns are changing underneath a country of 300 million people and the economy that we have, that is all at risk.
Yeah.
At some level, it doesn't matter what the underlying cause is. The society as we know it, the economy as we count on it, is at risk from these pattern changes. No business, if they saw their forward prospect shifting this much, would ban the word price change. They'd go try to get information about what the nature of the risk might be and how to prepare for what's coming. And that's slowly, too slowly, beginning to happen.
So what you're saying is they'll catch up once further evidence of this affects their pocketbook.
They're responding to the symptoms now. The resistance to shift the energy economy is just so disruptive economically, that's a tougher pill to
Probably got to
swallow.
worry about climate change. There's a zipper effect. If you go down the road too far, you can't recover. And so for anybody in the world that thinks climate change is a hoax or something like a couple of our people in Washington do, that's almost immoral.
But they keep doing it because they're getting paid off.
Yes, question right here.
I was wondering if, in terms of the negatives of the economic cost, if that outweighed the small abundance of water that you received from the planets and like having to build the tools and the crafts to actually get up to the planets, and if the economic cost outweighed the abundance of water you actually received and had brought back to Earth.
How old are you?
13, Mr. Tyson.
Man,
Are these guys all
what's
from
in the
same
water
school?
supply? Is that what we're talking about here? Heidi, why don't you take that?
Yeah, sure. So I make sure I understand your question, paraphrasing it. You're asking, is it cost effective to go and get water and bring it back here because it costs so much to get out there?
Yeah, I mean, it costs so much to build the crafts to actually mine the water and build so much to build the crafts to get up onto the planets to retrieve the water. I was wondering if the
You're coming back to the scalability question. Does it even make sense to do that? And yes, it does cost a lot, but the goal is to, I would imagine, here's long-term thinking, not 20 years, not 30 years, but maybe 50 or 100 years. If there was a way that we could develop an infrastructure.
Okay, this is when you're 63. Okay, this is just what you're talking about. All right, go.
But life expectancy will be much longer, 30 or 40 years from now. So build an infrastructure where we don't have to rely on one-offs. And then you can think more reliably about getting some of this water back to us. Or maybe by that time, you know, and I'll pass this over to Ellen, but maybe NASA will have a system that we can actually be exploring some of these places and going to places we know there's lots of water, like Europa, for example. Then we don't have to worry about bringing it back here. But we will, I think, to address the concerns at the other end of the panel, we will have to be solving problems right here on Earth. I don't think that NASA is going to be able to solve Earth's water problems by bringing water to Earth. I think we need to change. We need to adopt mitigation strategies here on Earth on how we're currently using water and make sure that the cycles that we have are robust.
I can tell you this, if you go to Europa and bring water back, whatever it costs, you could probably sell it for a lot of money. Imagine, a bottled water from Europa. Oh my gosh, that would totally rock, right?
Awesome.
Yeah, I
You'd buy that one.
I think I'd buy I want to say, if you ever find life on Europa, they would be called Europeans, right? Is that what that... Life on Europa. It's Europeans.
I think that was already used somewhere.
Just time for just a couple more questions. Sarah, yes.
So
Get up nice and close to the microphone there.
all right. This question is actually for Dr.
Closer to the mic? Yeah.
This question is for Dr. Rousseau. I guess it's more of an idea-based thinking. You were talking a lot about how it's about 700 million people who don't have access to clean water now, which means
Is that right?
So, it's way more.
It's more than that by now, right?
So try to keep it in front of your face.
Just trying to get an understanding of if there was a product or a widget or an infrastructure that was based solely to fix that issue, where would it start? Would it be the transportation of the water because of the amount of time it takes, the amount of time they spend getting to that water source and bringing it back home? Would it be in the filtration process? Using low-end, low-budget options to make that happen? Something like that would be pretty effective as a product.
Right. So most of the places that I've been, people are walking far to get to clean water. So they're walking past dirty water to get to the clean water source. So I wouldn't say it's in the transportation of clean water from that. It's in the some method of filtering that dirty water, treating that local dirty water source. And there's a lot of really neat technologies. There are little straws that you can put in the dirty water and drink through, and low-cost technologies for filtering. So I think there are a lot of people working on that, and they'll be making progress.
I'm surprised every day I walk into a grocery store and there's a kiwi there for 50 cents that came from New Zealand. If you can bring me a kiwi for 50 cents from New Zealand, why can't you move water around? Okay?
I don't
know. I'm sorry, we have time for only 2 more questions. I'm going to take one from this aisle and one from that one. Sorry for the rest of you. Yes, go ahead.
So you were talking before about grabbing a comet and taking the water from that comet, but you said parking it somewhere. How would you, if you somehow managed to grab a hold of the comet, how would you manage to stop it? Because, there's not a lot of friction in space.
You're not supposed to ask that kind of question. I was just coming up with an idea. I was just trying to solve it. Now you got to get all technical on me.
So
how old are you? You're how much?
13.
13. Where do all these 13-year-olds come from? Damn. What's going to happen? What are we going to do? What? Why am I walking that way? I have no idea. So is there an orbital thing we can solve here, Ellen?
So when we were first looking at the asteroid retrieval mission, the option we've gone to is one that would grab a boulder off a large asteroid and bring it back. But the first concept we looked at, fasten your seatbelt, was to go and bag an asteroid.
A big bag.
A big bag. No, small asteroid, big bag. But the cool thing is, first of all, you have to match. The asteroid's kind of moving and tumbling. So you take your spacecraft there, and you get your spacecraft to be doing the same thing the asteroid is doing.
Well, if you have to catch up with the asteroid first.
Catch up
it's got its orbit around the sun.
Right. And then you get into orbit around it, and you synchronize your motion with its using your retro rockets. Then you bag it, and then you slowly, so that you don't rip your spacecraft or the asteroid apart, you slowly start firing your rockets to get it to start doing what you want it to do. And they actually did all the physics and math to work all this out. And they actually said, you know, we could actually do this. It was really cool. Physics, angular momentum, all kinds of cool math that you might think is not so fun. Really cool stuff.
And I just want to mention, too, that, you know, we've actually done something, we, humanity, I'm using we in a very large sense here, we have done something like this. The Europeans actually sent a comet, a spacecraft Rosetta to a comet, went into orbit around it, deployed the little lander. How many of you watched that? Little Philae lander? I mean, how cool is that, right? So we do have the technologies, as Ellen said. Your question, like, where would we bring it to? Well, that's the part of the equation we haven't solved yet.
Well, okay, but you'd have to, like, orbit it around Earth in some near distance.
Or you could put it around the moon. You could put it in orbit around the moon, or you could put it at a Lagrange point.
The Lagrange point. There are 5 Lagrange points. You would tell us what they are?
Sure. L1, Lagrange point 1 is the easiest to understand if you, we're just talking about the Earth and the moon.
So here we are.
Yeah, so you got the Earth here and the moon there. And you can imagine that there is a point in here where the pull from the moon, the gravitational pull from the moon, is the same as the gravitational pull from the Earth. So if you put a little bead there, or a spacecraft, or a comet, it would just sit there. That's a gravitational stable point, Lagrange 1. Lagrange 2 is on the other side. Yeah. Lagrange 2, did you hear me? Did you hear any of it?
Yeah.
Lagrange 1 is here, Lagrange 2 is here, and I can't remember which are 3, 4, and 5. They're sort of scattered.
3 is 1 million miles away from the Earth on a line to the sun. We have a spacecraft on its way there that will arrive in June.
So these are gravitationally stable points where you can put stuff and it'll just stay there. And in fact, we are exploiting this fact with our spacecraft. James Webb Space Telescope, the follow-on from the Hubble, is going to L2. That's the Earth-Sun L2, I think.
Yes,
not
that's
the
correct.
Earth-Moon L2.
Yeah.
So you put it there and it hangs. And it doesn't fall anywhere. So that's where, so if we're gonna lasso a comet, if you're gonna bag a comet, you stick it there, you go up, scoop out some water, go back, at whatever, however you want it, often as you want.
Earth Moon L1. We didn't answer the gentleman's question about accomplishing the orbit change.
He's 13.
He kind of put his finger right on the soft spot.
How do you accomplish it? And by the way, the bagging part, not to speak for you, but I want to get this out there. Remember we said earlier, the structural integrity for many of these objects, first is unknown to the precision we need, but also the ones we do know about, it doesn't take much to break them apart. So you can't just start tugging these things around and expect them to stay as some solid piece wherever you put them. So that's a big issue here about how you're going to move around stuff in the solar system, these smaller rocky bodies.
But once you control its spin and its orbit, then you fire your rockets and you change its orbit. So it's all in bringing a lot of fuel with you.
You are the last question, so it better be awesome. The pressure's on. Okay, go.
Okay, so I don't know if any of you are fans of musical theater, but there is this...
That's a segue for you. I haven't heard that one. Whoa. Okay.
There's this musical called Urinetown, and basically it's about this severe water shortage in this town.
Urine spelled U-R-I-N-E.
Yes.
Yes, okay.
Yes, P-Town. Basically, there's like this class system based off of who can afford water and who can't, and it's like there's this whole song dedicated about how it's a privilege to pee and you have to pay to go to the bathroom, and then there's like riots about it. So do you think that a system like that, like where water will become so scarce and valuable that even if you had access to it, it would be only in the higher echelons of society, and then the lower echelons would just be hanging in bushes and drinking their pee and stuff
So the
like
new
that?
class system, the rich people get water, the poor people don't. The reason why that's unstable is because the rich people need the poor people to mow their lawns. So they have to keep them alive. That's my solution to that. What do you say?
Well, you touched on a great point, because a premise of water globally has been there's a public good, there's a moral public good dimension. Even if you start to put a price on water, somehow we have to make sure that even the least of us have the water needed to survive. So, Chuck and I have talked and alluded to a bit, it's a penny a gallon, that's nonsense. It's more precious to us than that. How do you put a price signal on it that starts to change behavior and incentivize the kind of technology investments we've been talking about without creating the moral and social problem that you're talking about? No one knows that answer yet, but it's one of the real tension points on the decision about, do you price water? Do you turn all the municipal, publicly funded water systems, let them all become private sector operated, which will just be pricing tiers and subscription services, and too bad if you can't afford it? Or can you somehow build into that a public obligation, even for the private sector company, to make sure that everyone's got some key needs met? And then who gets to define what the some key needs are? So
I'll just tell you that we have got to never get even close to that, because human nature is such that people can be really ugly when they get to that point. That would be awful.
Quick reminders of our jungle roots, our caveman roots, like that. What we call civilization is in fact fragile. What I'd like to do, if I have the whole panel, toast you, the audience, with a sip of water. Could you grab, I don't have a glass, so I gotta use the thing. All of you, thank you for coming for this, the 16th Isaac Asimov panel debate. We toast you all. We'll see you again next year. Thank you.